Hello and welcome to, sadly, the last in this series of the Lawo Lounge. Over the past 8 weeks, we have informed, educated, and I hope entertained along the way, as we have introduced you to the faces and technology of our company. In this week's show, we are looking into all things timing, as PTP is put in focus. We will show you how Lawo has all the tools to ensure that you don't get lost in time. Also, coming up, we visit Portugal to see the largest 2110 infrastructure installation in Europe. And in our Did You Know segment, we look at a very unique but little known feature of our MC² console range. So stay with us for this and more. But first, did you get the questions right in our 50-year quiz? Last week we made it just a little bit harder as we gave you 2 questions to answer correctly, both on the topic of Lawo's distributed multi-view solution. The first question was, what is the maximum number of pips possible to be displayed on a single head of the DMV? The answer is an incredible 128. The second question was, what is the name of Lawo's real-time multi-viewer setup tool included with every DMV system? It is, of course, the wall. Now remember, you needed both correct to win. If you did, Lawo goodies may already be on the way to you. Thank you to those who have participated throughout this series. You can be sure we will be back with the 50-year quiz in the next series of the Lawo Lounge later this year. Now, over the past 8 weeks, we've met a wide selection of our talented staff who make up our fantastic team here at Lawo, spread right across the globe. This week, I kept it very close to home as I wanted you to meet an important member of the management team based at our headquarters in Germany. An individual who usually prefers to stay firmly behind the camera. I luckily managed to persuade him to sit, just for a short while, in front of the camera, so you could all meet and greet Uli Schnabel, Lawo's Chief Operating Officer. Hi Uli.
Hi Jamie.
Hi. So thank you for agreeing to be our last guest in this series of meet and greet at our Lawo Lounge. Perhaps I left the best for last?
Thank you, Jamie. You're much too kind.
Now, I've been asking my previous guests to tell me a little bit about their Lawo story. So tell me shortly the story of Uli at Lawo.
Oh, good question. How long do you have? Okay, to make it short, sure. Straight after my studies of audio and video technology, I got a chance to work for a German public broadcaster as an audio engineer at this time. And sitting behind the Lawo console, I had to recognize that my enthusiasm for the technology was much bigger than for being an operator by myself. And that's how I found my way to Lawo. And actually, I'm still happy to be here. After, I would say, almost 20 years of most diverse challenges and a journey which hasn't been boring at all. Starting in a sales and project department, product management for routing systems and radio at a later stage in time. The great opportunity to work closely together with Philip Lawo, being his right-hand assistant on the CEO level. And then the really awesome opportunity to take over the operational business division afterwards, going through a permanent change. Even if this is a very personal story, I would say, and I think this journey properly reflects a very important part of our culture and success actually, to always reconsider the best approach to reach our targets, to serve the superior goal to the best you can, and to develop yourself together with the company by never stopping to question yourself.
Well,
that's it.
That's quite some story. I did say short, didn't I?
You asked.
Now, as the Chief Operating Officer and a fellow management board member, I know that you are the oil that makes our Lawo engine run so incredibly efficiently and smoothly. So tell me, What's your secret to success?
Thank you, Jamie. But actually, I would prefer to talk more about my personal motivation and philosophy and leave the assessment of success to someone else, especially as our success is only achieved by collaboration of so many. That's definitely clear. So regarding myself, I am driven daily by the question of how best possible collaboration leads to maximum results. And this all starts with the human being, with trust, with respect, with reliability, and with commitment. I don't believe in methods and processes by itself, as none of them could have any good ideas nor solve any problems, and they are just exchangeable. Yes, of course, you need to structure and you organize your company in order to avoid chaos, but this is only a means to an end, and the real value can only and comes only from those persons who are involved. Thus, in this regard, my personal challenge is, or I understand my personal challenge, to create, provide, maintain, and to develop further on an environment for all our colleagues which allows them to contribute with all their expertise and strengths in the best way. By keeping us aligned and sorting out any roadblocks and always to find the best approach. And you can be sure that this mission is never completed, and as the answer to this is different today to the one tomorrow, right? And in addition, I think this idea is actually not restricted to our company by itself. Because working with Philip Lawo closely together for so many years, I always admired his attitude to success, that success always bases on partnership. To reach goals by working closely together with a mutual understanding for the requirements and needs of each other. And that's from my point of view, what is really a core to our success. Be it in collaboration with our colleagues, with our partners, with our customers, just to be successful together. So that's my philosophy and my understanding of it. And but maybe it's also a very interesting question to you, Jamie, right? What is your secret recipe of your success?
Well, thanks for asking. I think it wouldn't surprise you to know that it's actually, I agree completely with all of the things that you've said. Of course, from my role and responsibility as the Chief Commercial Officer, I see there's two things which I have focus on. One is that I'm very, very lucky to have an extremely talented team around me, and it's my job really just to empower these talented people to be successful themselves, and that's really, really an important point for me. The second point, I think, as I'm actually the ultimate responsible to our customers, I'm looking after not only the reputation of Lawo, but also the reputation of our customers. So not only our customers, but if we think about our customers, taking care and understanding their needs and their requirements is going to support our own customers. So I think these are really important factors for us and really what have brought us the success which we have had over the years. Not forgetting, now we're in 50 years of the companies, and it's quite an incredible achievement. So yeah, absolutely agree with you. And you've heard, the audience have heard through the weeks that the culture at the company is a very strong part about Lawo. And I know you and me and our other colleagues on the management board are very keen to maintain this very entrepreneurial culture we have at the company.
Yeah, and it's really great to be part of it.
Yeah. Now, moving to the last part of our interview, it's what I call the speed dating question round. I've gone through it, so I think there's no escape for you, unfortunately. So, are you ready? Choice?
Should I be
No,
afraid?
you don't. Are you ready?
I'm ready.
Let's go. Starter or dessert?
Both. Don't you agree that the main course is the least exciting part of a meal?
Well, it depends. If I can have steak for a starter, then I'd agree with you.
Touché.
Okay, I know the answer to this one. Audi or Mercedes?
I take what I get, Jamie.
No, you don't. I know what you have. A cultural question. Painting or sculpture?
Painting, if you don't let me choose music.
Yeah, I agree. I like paintings. So, a very German question for you. Bratwurst with or without mustard?
Needless question, Jamie. Mustard is a must.
Okay. Now something about your personality. 130 kilometers per hour or 180 kilometers per hour on the German Autobahn?
Why should I stress myself on the road, Jamie? I go for a relaxed ride.
I know which car you drive. So, tell me, are you a hot person or a cold person?
Definitely hot, heat. My ideal operating temperature starts at 25 degrees.
Yeah, I think mine's similar. Okay. A film question. The Godfather or Psycho?
Just when I thought I was out, they pulled me back in.
All right, stay with culture. Opera or Rammstein?
Oh, that's me. Don't you think this is a much too restrictive question to a music lover?
Still avoiding my questions. See, you can't avoid this one. Whiskey or cognac?
Quality, not quantity.
What does that mean? You mix them together? I don't know.
I didn't say that.
And lastly, tea and cake or espresso and chocolate?
Oh, come on, Jamie, this is a rhetorical question, isn't it? Espresso, chocolate, cake, in this order. But what's the funny thing called tea?
It's a very English thing, as you know. Anyway, surprise, surprise about your answer, because you are very famous in the company for having chocolate in your cupboard to offer your guests for meetings. So no surprise there.
You're welcome.
Uli, thanks for joining. I know that you love to be behind the camera usually, so I really appreciate that you came out in front of the camera this time. So thanks for that. Hope to see you soon in Rastatt, okay? You take care of yourself.
Thanks for inviting me, Jamie, and take care.
Rock-solid timing and synchronization have always been critical to broadcast infrastructure, both in the audio and video domain. This is even more critical as complete media infrastructures are built on network technology. Understanding the important aspects of PTP and having strong tools to monitor and diagnose timing issues are key elements to ensuring error-free 24/7 operation. Andreas Hildebrand is here to explain to you how to avoid getting lost in time as we go in focus with PTP.
Thank you, Jamie, for having me today. It's an honor for me to present about the role of PTP in IP media. Please allow me to introduce myself first. My name is Andreas Hildebrand. I'm working for ALC Networks out of Munich in Germany. ALC Networks is the company behind the Ravenna IP media networking technology, which celebrates its 10th anniversary this year. And as you may know, Ravenna as a technology is fully open and license-free, and it's fully compliant to AS67 and SMPTE SD 2110. So let's jump into the topic of the day. Let's talk about timing and synchronization. First of all, we certainly need to know what general requirements exist. So, of course, one of the most important requirements is that we have full media bit transparency, so no sample rate conversion should occur at any point in the processing chain or distribution chain. And also that requires that all streams need to run on the same media clock. And I mean the very same media clock, not just nominally the same media clock. Also, in a network situation, I definitely want to be able to transport streams with different sample rates or media types concurrently on the same network, just like video, audio, or audio with 48 kilohertz and with 96 kilohertz. I definitely want to have a determinable end-to-end latency, and of course also a very low latency if possible. And I definitely want to be able to time align between any number of media streams which belong to the same event. Let's say a camera stream and a microphone stream capturing the same live event, or a number of microphones capturing the same audio event. So, and of course, once I have a network in place, I want to get rid of any so-called house clock distribution. So I don't want to have a green cable, word clock, blackburst, whatever, running around connecting to every device, as I already have a network connection to the devices. So from the above requirements, it clearly follows that clock reassembly from incoming stream data is not appropriate. So devices cannot just synchronize on any incoming streams. And also the pure distribution of master clock beats, just like with the house clock distribution, is not sufficient because we want to have absolute time alignment. And that in turn requires that within our media networking technology, we definitely have to have a common understanding of absolute time within the whole system. So there needs to be a wall clock which is valid and referenced by each and every individual device. So what accuracy requirements are we talking about? Well, if we look at typical production situations, we can conclude that the audio application usually have the highest time accuracy and precision demands. So if we want to sample accurately align any two individual microphone or audio streams, we need a time precision of at least plus minus half a sample, which translates at 48 kilohertz into plus minus 10 microseconds. And if we increase sample frequency, we need even tighter synchronization between those devices. And if we go one step further and want to achieve the precision which we can achieve with the distribution of a word clock reference, which is defined in AES 11, which calls for plus minus 5% maximum jitter and wonder of a reference clock. And then at 48 kilohertz, that translates into a time precision requirement of plus minus 1 microsecond and goes even into the nanoseconds, 500 plus minus 250 nanoseconds when increasing the sample frequency. Okay, so how do we achieve this in IP media networks? First of all, the first requirement is that all nodes are running local clocks. Well, however, those local clocks need to be precisely synchronized to a common wall clock utilizing PTP. So what exactly is PTP? PTP is an abbreviation for Precision Time Protocol. There is a standard defined in the IEEE 1588, and that is a protocol or a method for distributing a very precise, sometimes GPS referenced time over an IP network. Now, this technology is used in multiple industries, and of course it's also not just used in Ravenna but also in AES67 and SMPTE SD2110. Both use PTP with a certain profile. Now, PTP has initially been standardized by the IEEE in 2002. That's called the PTP version 1 protocol or definition. And IEEE followed up in 2008 with the PTP version 2, which improved the accuracy, the precision, and also the flexibility. And the pity is that both versions are not compatible with each other. So a PTP version 1 client cannot run in a PTP version 2 environment or vice versa. Now, some of you may have heard that PTP has released just recently a new version of PTP. It's called PTP version 2.1. Just has been released in 2019, end of 2019. But the good news is everything is fully backwards compatible. So I'm not running you through the improvements and the new features which have been added, just that you have seen them on a slide. You can study them on yourself later on. We have improved robustness, we have improved accuracy, and we have improved flexibility definitions in 2.1. But the key point is and remains, it's full backwards compatible to version 2. So any PTP version 2 slave will perfectly sync with a new version 2.1 Grandmaster, and of course also vice versa. So now that we have all the local clocks in all the devices precisely synchronized to our common wall clock, then all these individual devices can generate whatever media clock they need to generate. So an audio device can generate 48 kilohertz. A video device may generate the 96 kilohertz or whatever it requires. And here's an illustration how that will work. We will have a master clock in the system that can be referenced to GPS. In professional application, it usually is referenced to GPS or any GNSS source. We have all the devices, we call them slave clocks or nodes in the network, and those are synchronized through the PTP protocol very accurately, very precisely. And once we have precise copy of the master clock time in the individual devices, we can set them to generate their media clocks locally, independently from each other. But since the clock is referenced and precisely referenced in the master clock, the resulting media clocks will also be fully in sync frequency-wise and also phase-wise. So if I generate 48 kilohertz and have all of these devices and look at them at an oscilloscope, they will perfectly be in line with very, very little variation over time. And of course, through that scheme, the generation of any desired media clock is possible. So I can also set a device to operate at 44.1 kilohertz, another device at 48 kilohertz, and so on. And that means that the concurrent operation of different media clocks on the same network is possible, although it might not be possible, of course, for a device being set to 48 kilohertz to receive a stream originating from a device set to 44.1 kilohertz. Now, I can also achieve phase accuracy as defined by AES11. I may have to deploy PTP-aware switches in the network, which increase, by design, the accuracy of the PTP protocol. So those PTP-aware switches are switches which natively understand PTP messages. They are called boundary clocks or transparent clocks. Then I have, in very typical remote production situation, of course, the need to synchronize very precisely across different facilities. And that can also be done by not distributing the time with the PTP protocol across the distance to the remote connection, but by using local grandmaster devices which are referenced to the same GNSS source, to the same absolute time, GPS, International Atomic Time, or any other GNSS source. Now, once I have synchronization among all the devices in place, I can start taking data in. So if I have an audio device, I can use the media clock, which I have generated locally, to sample my audio. And whenever an audio sample is being generated inside the device, it is essentially receiving an absolute generation timestamp with respect to the media clock or the time reference behind it. Now that sounds a bit complicated, so I have another illustration prepared for this. So in a typical system, we have a sender device, we have a receiver device, well, we have many of those devices, but for now we just have this in the illustration, and we have a reference clock, usually called the PTP Grandmaster. Now, all these devices have their own local clocks, but they are fully synchronized and accurately following the time reference. So the local clocks carry identical time, and now from those local clocks I can generate media clocks locally. Because the media clock generator is directly coupled to the local clock, all the media clocks generated locally independently are exactly the same in all the participating devices. So now I sample my audio signals and generate a stream. Now the standard which is being used for transporting the stream, it's called RTP or RC3550, defines its own RTP stream clock, but luckily enough it's not an independent clock. That RTP stream clock with our PCM audio, with our linear audio or raw video, is directly related to the media clock, which in turn is generated out of the system reference clock. So that stream data is being carried with the same synchronization, with the same relationship all over the place. Once I have a timestamp with every particular sample, actually in a really working system, not every sample would have a full generation timestamp because it's not necessary. Once you have a determinate media clock running, you can simply count the media clock cycles from the reference point in time, and then you exactly know when a particular sample has been generated. Well, if you're receiving a particular sample and exactly know when that particular sample had been generated, you can also determine or configure a suitable link offset, and that stays fixed throughout the lifetime of that stream. So in other words, once you set a particular suitable link offset for a receiver for a particular microphone stream, let's say to 2 milliseconds or 10 or 5 milliseconds, whatever suits the particular needs of your application, then that stays fixed for the lifetime of that stream. And of course, if multiple streams are being received, inter-stream alignment can simply be done by comparing and relating the timestamps of the individual essence data with each other. So in other words, if your left and right microphone stream, they both carry their generation timestamps for every sample, and the only thing the receiver needs to do is to time align the incoming samples for combined playout or further processing. And of course, the same is also true for audio together with video images, which are transported by individual essence streams as being defined in SMPTE ST2110. In a typical production workflow, this might be a picture illustrating the situation. We have a camera or video flow originating from a camera. This might be run through several processing devices. We will always have a link time between these devices. We will have processing time within the device. And finally, we have a designated playout time. So we have an overall link time. And we might have another audio stream coming from the microphone just sitting next to the camera, which may, in this example, just run through one processing device. Sound mixer has its own link time between microphone and mixer, and also between mixer and playout device. And what we want to achieve is the absolute exact matching play out of both essence streams. And this can be done by telling the speaker device, in this case, or the playout device, by holding up the stream data for a particular time which matches the time the video stream needs to pass through all the processing devices and finally reach its playout device, let's say a screen here. So basically someone has to set a delay or a buffer time for the playout of the audio stream to hold it up just to match the link times or the processing times of the video stream. So how is that basically be done or achieved? Well, first of all, you need to know and understand that all those devices definitely have those buffers. They are needed to cope with packet jitter, which may occur in a network, because typically on a network, streams are sent in packets, and those packets are not forwarded in the very precise manner they are originating from a sender device, because there are other packets on the network in the way, or they might be routed and being held up by other packets trying to just go down the same link or route as the particular packet I'm looking at. So they might receive some packet jitter, and those buffers are always needed to eliminate the packet jitter. Packets may occur or may get through the transport on the network. And so now a broadcast control device or a management system can exactly tell those devices what individual buffer times they have to use. They get a report what the processing times of essence data inside the devices is, and then it can calculate finally at the end the required delay time for the final buffer of the audio essence in order to nicely align the camera essence, which runs through several processing stages, and the audio essence, which has a very shorter way in terms of time, in order to align them for the playout at the final devices. That's the way it works with the alignment in such an IP system. So finally, I want to give you some hints and some guidelines to understand what factors impact the achievable precision in an overall system. So we have several instances working together. We have the grandmaster, and of course the accuracy of the clock reference might be one source of uncertainty. So if you're very precise grandmaster, maybe it's even reference to GPS, you usually have a very, very good reference there, but you might also have a free running device if there's no need to reference your time to GPS because you're just running locally, let's say within an OB van or within a local studio setup. Then the quality of the internal oscillator of the selected grandmaster device might already be not as good as GPS reference, but still good enough for your local production. Of course, the availability of the grandmaster device poses another factor. which might impact the precision, because if the grandmaster vanishes, maybe it's just you getting a failure, or somebody has plugged the network plug, or the even worse, the power plug, and it goes out of service. Another device is automatically taken over. This is part of the PTP standard, the PTP protocol, selecting the next best available grandmaster. But if you don't want to if you don't want this happen, you're better off designing your system with a grandmaster backup device, which can automatically take over with the same quality. So it's a standby GPS reference grandmaster in a professional production, which should be in place. So the slave or the end nodes themselves are may have factors which impact the achievable precision, because those have the clocks, and those clocks need to follow the reference, the grandmaster, and that is done through evaluation and the calculation and mathematics with the PTP message they are getting. So the message frequency may impact the achievable precision, the frequency of the delay request, and then the announced messages may affect how fast a end node can settle on the reference time and stay synchronized to it. And also the build of the internal clock implementation. What is the filtering with false packets, with outlier detection, mean value, whatever mathematics can come into game. The PLL characteristics, which you can have fast PLLs or slow settling PLLs. They all affect the precision of the overall system. So these are design choices made by the manufacturers, whereas things like message frequencies is a setup choice, a configuration choice during system operation. Then the network itself can contribute or impair the achievable precision. Topology, size, availability of the network are always factors. You can easily understand that a large network with quite a lot of switches between grandmaster and end nodes may achieve the precision you can gain out of the PTP, because also PTP packets may be prone to jitter on the network, and it might require in turn to insert some PTP over switches in the network. The link speed has a direct effect. The higher the speed, the less the packet jitter comes into game. And also mean bandwidth utilization, dynamic traffic situation may all impact the achievable precision. So we have countermeasures for that. Standards are QoS, quality of service, which prioritize PTP as well as media traffic against the common traffic on the network, or other traffics like Office, web browsing, whatever you have there. As I already mentioned, deployment of boundary and or transparent clocks definitely improves the precision on your network. May not be required in smaller networks at all. And of course, if you really have a mission critical situation, you better off with scheduling or planning or going ahead with redundant networks, and not just redundant GM devices, but also fully redundant network, like with a redundant spine leaf infrastructure or architecture. And the mechanism to follow there is SMPTE SD 2022-7, which nicely describes how you can stream a particular essence streams on 2 or more redundant network connections. That basically concludes the presentation of the role of PTP in media net development. You have learned from the last slide that there are a lot of factors, and it's a lot of factors which can impair the achievable precision of your time and synchronization. And of course, you want to know, what is the performance of my network with respect to PTP? How accurate am I really getting? Where are potential problems in my network, or if something is not working, where's the problem? And of course, you need some monitoring tools for that before the problems even occur. And that brings in Lawo's SmartScope application, which has some very, very nice mechanisms and tools aboard to particularly monitor the situation of PTP distribution in your particular network setup. And that brings in a live demonstration that, which is being hosted by Rafael Severo, who's working for Lawo, is a project and pre-sales engineer. And I hope the connection is in place now. So Raphael, please take it from there and let us see quickly how the Lawo SmartScope is working with respect of PTP monitoring. Raphael?
Thank you, Andreas. Welcome everybody to the Lawo Lounge today. My name is Rafael Severo and I work as a project engineer at Lawo. And I would like to show you some features of our monitor system called Smart. The Smart solution is composed by two applications, the Smart Dash and the SmartScope. Here in the Smart Dash, we can see the whole network infrastructure of your environment. And if we click here in one specific device, in this case the Rastatt switch, the dash will show us a lot of information about this specific switch. Here we have information about the model, we have information about the software version of the Rastatt switch, we have information about the power supply, the CPU, the RAM utilization of this specific device, and also we can see here the total number of interfaces of this Rastatt switch. If, for instance, I click in one specific interface here, we can see here the bandwidth utilization of this specific port, and also we can see the IGNP groups, the multicast groups that we have for this specific interface. Another function that we have here in the Smart Dash is related with the PTP. One very important tool is to check if the whole environment is in sync, right? In that case, we have here the PTP status, and we can see that the PTP status of this specific network of this specific switch is okay. And also we can see the priorities of this specific grandmaster and the domain number. Here we can see also the grandmaster ID, which means that we can check the exactly MAC address that we have in our environment if it's fit with this one here inside of the switch. Another very good tools here is that we can see the mean path delay and also the offset from master. Two very important tools in this specific environment. In the network environments, it's very important to see from where and to where we have these specific groups, okay? And this feature here can show you the exactly port and group, the multicast group that we have for each specific port. For instance, we can see that this group here is connected to the port for one of these switch. And the same thing for the other groups that we have in this switch in the network. As I mentioned before, the Smart solution is composed by two different applications, and the second application that I would like to show you is the SmartScope. SmartScope works as a probe in your network, and you can receive streams in your network and check the health of these streams. Okay, and one thing that we can see here in the overview page is you can select the specific stream that you want to see, and here you are able to check the PTP status of this stream. You are able to check the bit rate information for this stream, and also information about the transport, package telemetry, and package pacing. And here you can see also the information about the resolution of the stream and the format of this one. In this specific case, we are talking about the 211020. In the SmartScope solution, we have also another parameter that we can see inside of the service time sync. We can see the offset of the PTP related with the time. It was a brief of our Smart Monitor IP PTP application. If you want to try out this by yourself, you can download the trial application in the link below. Okay, thank you for your time and stay healthy.
All right. Thank you, Rafa, for this very, very interesting demonstration. As you can see, the Lawo SmartScope is a really powerful application to monitor the situation in your network. So it's one of the very, very highly recommended tools. Any resources of interest you'll find on the Ravenna webpage, and the resources, of course, and particularly for PTP, I want to point out that Meinberg, who is a Ravenna partner and a very professional manufacturer for PTP equipment, has very, very interesting and informative resource pages on PTP, which you can find on the URLs just presented in my final slide. So thank you for having me today, and that's it here from Munich, and I'll give it back to the Lawo headquarters in Rastatt now. Thank you.
Hello everyone, it's Frank again from Lawo. Did you know that you can pre-listen to your EQ, your filter or any of the dynamics modules before you insert them into the signal path? Let me show you how to do that. So to activate this function, you press the touch sense in the central section, and the moment it's blinking, whenever I adjust any of my modules, it will go into pre-listen mode. So if I adjust my EQ, I can look for a frequency and filter out this annoying buzz. And the moment I'm happy with it, I can then turn on the EQ. Same with, for instance, the threshold of the gate. If I want to set the threshold to a safe level so it won't gut into my audio too much, I can adjust that, and the moment I'm satisfied, I can turn it on. I can do that for the gates as well as the compressor limiter and expander, and also for the EQ and filter bands. By default, this is set to momentary. So the moment you release the rotary, it will also turn off the listen mode. If you want to set this latching, you can go into the settings, into the listen mode page, and set that from sense to latch. And now whenever I touch a module, it will go into listen mode, and it will stay into listen mode until I disable the touch sense function. So there you go, now you know.
Today we are introducing the Lawo LVP LiveView multi-image processor. The LVP is a software-defined solution that operates on readily available COD server architectures and is the perfect teammate for Lawo's vMatrix DMV distributed multiviewer. But it can run also as a self-contained system. The LiveView processor is designed for head-end and transmission infrastructure systems to allow for compliance checking and monitoring of compressed video signals. The LVP system can subscribe to many signals concurrently that are compressed using a variety of encoding formats, including MPEG-2, H.264, HEVC, J2K, and OTT ABR flows. It analyzes and monitors these flows for compliance and creates LiveView mid-map streams for each of the compressed streams. Lawo's vMatrix distributed multiviewer can include these streams alongside with any SDI or ST2110 live production signal in its mosaics, allowing to show uncompressed and compressed videos side by side on the same multiviewer head. This makes the vMatrix DMV the perfect IP multiviewer choice not only for live, but also for playout, head-end and transmission applications. For more information about Lawo's LVP LiveView multi-image processor, please call your Lawo sales contact or visit lawo.com.
Now, for the last in this series of On the Road, we visit the brand new SiC facility in Lisbon, Portugal, which went on air last year with IP at its core. Embracing the technology change with full commitment, take a look at one of the largest end-to-end SMPTE 2110 facilities in Europe.
This is a passioning activity because you are challenged every day. 24-hour news operation is quite demanding. The competition in Portugal is very hard. SIC is the first private television network in Portugal. We run 9 channels, one 24-hour news channel, a main channel, a satellite channel, and among these 9 channels we run a few cable channels.
Changing from SDI to IP. We are the first, I think, in the world to put it running in such a short time. One of the goals is to deliver these studios all working in about 4 months of implementation. That was a big challenge. I'm very proud. It was the project of my life. The key factor for this project was the people and the systems that we've chosen.
We had to think about what the industry was offering, what should we choose in terms of technological platforms. We trusted in what Sony proposed us, and Sony came together with Lawo.
Lawo, Sony and Cisco were the key components of the system. Cisco managed all the network interconnections, and Lawo as the processing power, and Sony as the vision mixers and the cameras. We use Vmatrix C100 modules with multi-viewers, gateways, and UDX. The reason to choose Vmatrix was mostly related with the flexibility, and by that time there was some similar products but not with that potential. Since some of the signal sources are still in SDI, we choose to go in a mix. Let's say satellite receivers, fiber optics interfaces, and all that kind of signals are SDI. So we have an SDI to interface the incoming signals, and then we route it to IP, but all production control rooms and studios are all based on IP.
The most important thing is the flexibility the IP bring to this area, having the production control rooms operating in kilometers of distance. That's very important.
If you have network redundancy guaranteed 2022-7 together with the control systems as we have here, like VSM, IP, definitely makes your life easier. VSM is quite powerful. When you have fixed studio operation, this is really a quite powerful tool.
We were looking for VSM for a long time now because we understand that flexibility and the possibility of making change on the fly. We can have some setup in one production control room, and for the next program you can have another one completely different. Recently we had an election, and usually in previous elections we have to do lots of cable changes, and with the VSM it was very easy. If it saves times, it saves money. With news, it happens all the time that some director wants something new. If you all the time you have a new idea, you have to run cables or change things, and in the previous way it was much more difficult. Now with the VSM it's much easier. We have a 24 hours news channel, so that studio and production control room is almost all hour running, so it's a good proof of stability. I'm proud to participate in this project because it's always fun to touch new technology. This is on the edge of the technology.
This was quite difficult and quite challenging for us. We stayed here for very long days and many nights, weekends and so on. We just were absorbed by what we needed to do and to accomplish. And when we started walking around, looking behind, we were not believing in what we did, so that's the truth. So it was a bit difficult to control all the emotions, so there were a few tears that came along our faces, of course.
Sadly, we have now come to the end of this episode, and in fact, the series of the Lawo Lounge. I would like to say a big thank you to all of you for joining us every Wednesday for the past 8 weeks from across the globe. It's been a real pleasure to welcome you here in my home, from the kitchen to the dining room, and of course from here in my lounge. I'm hoping the next series I will be able to host you from our headquarters in Germany. I would also like to take this opportunity to thank all my colleagues who have been working so hard over the last weeks to entertain you with interesting and relevant content. I know from your feedback that you have appreciated the diversity of our topics. Now, we will be back after the summer for another series of the Lawo Lounge. So until then, as I've always said at the end of each show, please take care, stay healthy, and stay connected. See you soon. Goodbye.